Okay, so today we continue to look into the graphing of the rational function. And when we want to sketch a graph, what we should show on the graph? What are the important things for each graph? Axis-intercepts, asymptotes, and turning point. How we can find the turning points? We have function, we want to graph function y equal f of x. How we can find the turning point? We're finding derivative and equalizing it to 0. And we're finding the turning point. Now, how we can decide, because there are 3 types of turning point. What are those 3 types?
Stationary,
like stationary points. Maximum, minimum, and stationary point of inflection. Underline stationary. We will learn about non-stationary points today. Non-stationary points of inflection. But then we found that for certain values of x, there is a stationary point. How we can find what type of the stationary point it is that? We can find the second derivative. Have you been doing in methods second derivative, or you were doing this sign diagram?
We did.
So second derivative. We're finding second derivative of the function. And if we have, we have f dash of x equals 0. And if we have second derivative is greater than 0, what that will be?
minimum.
That will be minimum. If we have first derivative equals 0, second derivative is less than 0. Maximum. Now, if we have first derivative equals 0 and second derivative equals 0, what is that?
You have to investigate because it might be on reflection.
Yes, we cannot tell anything. We need to investigate because that could be minimum, could be maximum, could be stationary point of inflection. But what the actually second derivative means for the graphs? What there, when we have first derivative does not equal 0 and second derivative equals 0, what does it mean for the graph? So if we have, for example, when we have the maximum, we have second derivative is negative. So maximum looks like this. That's maximum. And we say that second derivative here is negative. We say that this function is concave down. Concave down. So if we have the second derivative is negative, it is concave down. So when we have second derivative is positive, it's concave up. And if we have first derivative is not equal to 0, second derivative, so first derivative does not equal to 0, and second derivative equal to 0, that might be non-stationary point of inflection. Non-stationary point of inflection. Might be, because it has to be investigated. It's not 100%, we can just suspect. What does it mean, non-stationary point of inflection? We'll have that function turning from being concave up becomes concave down. And that is so function going like this, and then start going like this. And that point will be non-stationary point of inflection. In our graph in this year, we will not be required to find non-stationary point of inflection. Next year it will be. Just to prepare you for the next year. Now, so this year you need to find the stationary points and find their nature. To find stationary point, we need differentiate function. And let a couple of rules you might learn and might not yet. Product rule. Product rule for differentiation. If we have some function as a product of two functions, we have f of x equal u of x times v of x. If our function is a product of two functions, then to derive it, we can do the next thing. F dash of x equal u dash v plus u v dash. This is called product rule. Let's consider an example. Let's say find derivative of the function y equal negative 2x in the power of 4 minus 3 times negative 2x squared plus 1. So that is our u, that is our function v. What will be du over dx, or same thing as u dash equal?
Negative 8x.
So will be equal negative 8x cubed. What will be dv over dx equal?
Negative 4x.
Negative 4x. So applying the product rule, we will get that dy over dx, or f dash of x, will be equal derivative of u, negative 8x cubed, times v, negative 2x squared plus 1, plus derivative of v times u, derivative of v minus 4x, so we change plus to minus 4x times u, negative 2x in the power of 4 minus 3. And I will suggest it will not be a good idea to leave it like this. I suggest to take some common factors. What will be common factor?
Minus 4x.
Minus 4x. Minus 4x. So we will have here, we'll have 2x squared times 1 minus 2x squared. Here we have minus this gone, so minus minus plus, plus 2x in the power of 4 plus 3, and negative 4x. We have 2x squared minus 4x in the power of 4 plus 2x, so we have 2x squared minus 2x in the power of 4 plus 3. That will be final
Wait,
one.
what about the 4x squared?
So minus, we take negative
No.
4.
Like, isn't it negative?
We
2x?
take negative 4x out.
Yeah, but then you multiplied it by negative 1. You should have just kept it as negative 2x minus 3.
No, you forgot that 2x squared.
Negative,
minus
I take negative 4x, so it has to be minus here,
The 2x squared
and minus
2x
3, yes.
minus
You
2x
take negative out, yes. So that will be negative 4x squared will be negative 6x in the power of 4, yes, thank you. Makes sense how to apply product rule. U dash v plus u v dash. You find derivative of one function of the product, you find derivative of the second function, and you apply the product rule. Another rule that we will look today is a quotient rule. Quotient rule from the name when we have one function divided by another. So if we have f of x equal u of x divided by v of x, then derivative will be equal u dash v minus u v dash divided by v squared. That is a quotient rule of differentiation. When we have our function is a quotient of two functions, then we have derivative u dash v minus u v dash over v squared. So let's consider an example. Let's say we have f of x, y equal 4x in the power of 5 plus 2x squared over 3x in the power of 4 plus 5. So that is our u, that is our v. So du over dx will be 20x in the power of 4 plus 4x plus 4x. dv over dx is 12x. Then we substitute it into the quotient rule formula. We'll get dy over dx equal,
Right. Isn't that 12x cubed?
we have 12x cubed, yeah, 12x cubed. We have u dash v, so we have 20x in the power of 4 plus 4x times denominator 3x in the power of 4 plus 5 minus numerator 4x in the power of 5 plus 2x squared times the derivative of the denominator 12x cubed, and that all will be over the denominator squared 3x in the power of 4 plus 5 squared. And of course we can simplify that. We can take some common factors and try to simplify. We will do it now because we now will have a look how we apply all of them to sketch the graph of the function. So let's consider how we apply everything to sketch proper graph of y equal 16 minus x cubed over 4x. So let's sketch graph of the function, rational function 16 minus x cubed over 4x. I will suggest what will be the best way to do it. Any ideas? What will be the easiest way to sketch such graph?
Intersections.
Are there any y-intercept? Will be there any y-intercept?
No.
No, because we cannot have x equals. So we already get asymptote. X equals 0 will be asymptote. Now, but what we can do with this to sketch this graph? I will suggest split it into fractions. So if you rewrite this as y equal 4 on x, 16 over 4x will be 4 on x, minus x squared on 4. Split it in two. Now, we can use addition of ordinates to get an idea of the shape. To get an idea of the shape of this graph. So we have two graphs. 4 on x, which have two asymptotes. So 4 on x, different colors. This is 4 on x. And now how the minus x squared on 4 looks?
That is.
It is a negative x squared. So we have a.
That's why.
So we have parabola upside down. We have parabola which will be upside down like this. Now let's think how, when we add them, what we will get. Here, when we approach in infinity, x approaching infinity, this becomes very, very, very small. And this becomes very, very big negative. So what the sum of them will be approaching? It will be very, very big negative. So graph here will go like this. Now, when this becomes very small, this becomes very big when we add them, but it will be above because it's plus. Here will be exactly the same thing, but here we have negative plus even small negative, so it will be even more negative. It will be something like this. This one we already know is the asymptote. Now, to find what's happening here, when this going to the infinity, this coming to 0, so this graph should go like this. Now, let's find x-intercept. Will be there any x-intercept?
No.
Yes. X-intercept y equals 0. Y equals 0, then we have numerator equals 0, 16 minus x cubed equals 0. So x equal cubic root of 16, which will be 2 root 16 is 8 times 2, cubic root of 8 is 2, so 2 root 2. 2 root 2, which is approximately 2.8. So we will have the x-intercept. And so we will have graph going like this. 2 root 2, 0. Now, how it should go for very small negative x? How the graph will go here? This going to negative infinity, this is very small negative, so graph will be going like here. So it tells us, just looking and thinking, that there should be some stationary point, some turning point. Let's find this turning point. Let's find derivative of this. What dy over dx will be equal? dy over dx is easier in this form. Derivative of 4 divided by x, 4 times x and negative 1.
Negative 4x squared.
Negative 4 on x squared. And that will be minus 2x over 4 will be minus x on 2. So let's equalize it to 0. So we have equation. We have equation 4 over x squared minus x on 2 equals 0. 4 over x squared equal x on 2, we get x cubed. X cubed equals 8. Sorry, I've lost minus here, it's minus. Negative 4 on x squared. I'm looking that we're getting, so x cubed equals negative 8, x equals negative 2. So when x equals negative 2, we will have, and here, do we need to do analysis for maximum or minimum? It's clearly from our general analysis of the function, when x equals 2, negative 2, there will be the maximum of this function. And to find the y value, substitute minus 2. Don't forget that you're substituting it into the original function.
You asked how many negative went away?
Hmm?
Oh, never mind. Sorry.
So we substitute negative 2, we get negative 2 cubed negative 8, so 16 plus 8, 24, over negative 8 is negative 3. So this is negative 2, negative 3. So this is complete graph of that function. Makes sense how we build it?
Yes.
Question? Okay. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas. And unfortunately, it looks like maybe the United States will join them. Support Ukraine and Israel.